My name is Marcus Mason, and this is going to be our verification video. The system will start in a sleep position, and the server will start in a lock position. Upon a button press, the system will switch to the input state, and upon inactivity for 15 seconds, the system will switch back to the sleep state. When the user puts a pin in and selects the hashtag button, the system will then switch to the check password state. The system then checks the password against the saved password, and if the password is correct, it will go and lock. But first, it will check to see if the servo is blocked. If the servo is free, the system will unlock. If not, the system will go back to the input state. Now, when the servo is free, the system fully unlocks, and the servo goes to the unlock position, and the LED goes green and flashes. Now, if the user wants to reprogram their password, they can select the hash button. Now, the system will switch to the reprogram state. The system will then salt and hash the pin and then save to EEPROM, and the LEDs will flash red and green. Now, after reprogramming, the system will go back to the locking state, in which it will check to see if the servo is blocked, and if the servo is free, the system will go back and lock. And then after inactivity for 15 seconds, the system will then sleep. Now, if unlocked, and the user wants to lock the button back, they can press the star button, in which the system will then check to see if the servo is locked, and then lock. Now, going back to the check password, if the system determines that the password is incorrect, it will then switch to the error state, in which red and yellow LEDs will flash alternatively. Then, the system will go back to the input state, in which the user can try again. In terms of safety transitions, when the system is in unlocking and it determines that the motor is locked, it will go back to the lock state. When the system is unlocking and the motor is locked, the system will go back to the unlock state. Now, upon any state, after an activity, the system will go to sleep. And when unlocked, the system will go and lock the servo motor and then go to the sleep state. All right. Now let's see a demo of the system itself. All right. We just uploaded. Okay, sweet. So as you can see, the system starts in a lock state, but first, let's see if after inactivity, if the system goes into the sleep state. As you can see, the system just went into the sleep state and it reports to the user. Let's press the push button to wake it up. All right, as you can see, it's back on, reports to the user. So let's put in the correct pin to see if it'll unlock. So we'll put in the pin right now, which is 1111. As you can see, whenever you press the button, it reports to the user. All right, now let's press the hash button to unlock it. All right, the system is now unlocked. Now, let's lock it back with the star button. Now the system is locked. Now let's unlock the system one more time. All right, as you can see, the system is now unlocked. Let's check to see if when the servo is blocked, if it'll unblock. So let's wake it up. All right, let's input our password. Let's hold our servo. And you can kind of hear when it reverts. Or as you can just see in my hand, it just reverted. And it's still in the lock state. There's some additional features. As he just went to sleep in lock mode. ARP, sorry. And now, let's look at some additional features. So, As you can see, it's in lock mode. Let's unlock it. As you can see, that was an incorrect password. And when incorrect, the yellow and the red lights both shine. All right, let's put in our actual password, which is 5555. Sorry, we have to wake it up. Let's put in our actual password, which is 5555. All right. Now, we'll wait for sleep mode while unlocked. As you can see, or as you will be able to see, it reverts back before going to sleep.